In today's lecture, we will learn how to use Proc Tabulate procedure to get descriptive statistics in SAS. We will demonstrate the usage of the procedure using data sashelp.heart. The Tabulate procedure produces descriptive statistics in tabular format in 1 to 3 dimensions. You can create simple to highly customized tables using the procedure. It has the flexibility in classifying the variable values and establishing hierarchical relationships between the variables. Similar to those procedures we have learned from last lecture, it can generate printed output and output data sets. The basic form of the procedure is proc tabulate data equals dataset name, the table variable name, class/var run. At least one table statement is required in the procedure step. The table statement is used to define the table, including variables to use and the layout of the table. In addition, depending on the variables that appear in the table statement, a class statement or a var statement is required. Sometimes both class and var are required. The class statement specifies the class variables for the table. The var statement specifies the numeric variables to use as an analysis variables. For example, age would go into the var statement and gender would go into the class statement. There are 3 different operators to separate variables. Commas are used for table dimension, an asterisk is used for nesting, and a space is used for concatenation. There are different operands for the table statements. Class or var variables are the key component. Parentheses are used for grouping. Statistics keywords can be applied to get statistics for the specified variables. Var equals label adds descriptive text for variables. F equals format can help format the output table. The less than and the greater than signs are for specifying percentage denominators. The universal class variable all is used for to get total statistics. We will see some examples. Let's look at an example for the simplest tables for gender and age. Here in SAS, I have the code for this video pulled up here. This code is available on Canvas. I've also separated the windows so that I can see the log, and then eventually I'm going to place the results viewer here. So the first thing that we want to do is read in our data set. We can do that using this code. Notice we're reading in the sashelp.heart dataset. Once the dataset has been read in, we can now create the tables. First, we'll run this code right here. To make it easier to see, we will shrink the results viewer. Notice we listed both class and table statements as sex. This is the simplest table for a categorical variable. It shows the counts of females and males in the data set. Running the next set of code, here we listed age at start in both var and table statements. It produces the simplest table for a numeric variable. It shows that the sum of all ages in the data set. We can see that here. When we look at only one variable, the results are displayed in columns. The output tables have column headings, statistics headings, and then the statistics. We can also see that here on the slide. We have the column headings, the statistics headings, as well as the statistics. Proc Tabulate can also concatenate results from different variables into the same table. For example, we would like to look at the frequency of gender and smoking status. Let's look at SAS again. Looking at the next section of SAS code, notice we can put those two variables into the same table statement with both Proc and Proc Tabulate. We can see that here as well as here. Variable names are separated by a space. See the space here, here, and here. Running the code, Proc produces a table for each variable. On the other hand, if we run Proc Tabulate produces one table for both variables. From the results, we can see that the counts for gender and smoking status are right next to each other in the table. See that here. This is what is produced by the Proc Tabulate procedure. Again, here in the slides, we have the comparison of the Proc procedure as well as the Proc Tabulate procedure. In both of the examples on this slide, we will see the usage of comma in the table statement to control table dimensions. Again, we will look at SAS. Looking at the next set of SAS code, the variables before the comma are row variables, and the variables following the column are column variables when there are only two variables listed in the table statement. We can see that here and here. And each cell will be the count for the combination of rows and column variables. Running the code, the first table has gender as the row variable, so it displays counts by smoking status by gender. We can see that here. Running the next set of code, this table have both gender and living status as the row variables. It displays counts by smoking status by gender or by living status. We can again see that comparison here with the output on the slide. To summarize again, the table on the left has gender as the row variable. We see that here. So it displays counts by smoking status by gender. The table on the right, looking here, has both gender and living status as the row variable. It displays counts by smoking status by gender or by living status. What if we separate the three variables with two commas? Again, we can look at SAS. Running the next section of code, the table dimensions are page, row, column. We can see in this example the procedure creates a table for each gender on separated pages. Each table displays the counts by smoking status, by living status, and by gender. The highest dimension of the table is page. So scrolling through here, we can see the three separate pages. Here we have the page for just sex female, here we have sex male, and we have the status alive and dead, as well as the smoking statuses. Again, looking at the slide, we can see from the output that the horizontal line is the page break. So here we have sex female and sex male once again. This example will demonstrate the usage of asterisk to create a table with nesting. The variable following the asterisk will be nested within the variable in front of it. Looking again at SAS. We can see here we have the nesting code. Here we have an example with one asterisk. We can see that smoking status will be nested within gender. Running the code. The table is in an all-column format. Each cell represents the count by gender by smoking status. Multiple layer of nesting can be created with multiple asterisks. You can try this on your own. So far, we have looked at several ways to produce a simple table with Proc Tabulate. Let's look at some more complicated examples. The universal class variable all summarizes all of the categories for class variables in the same parenthetical group or dimension. Note, if the input dataset has a variable named all, you will need to add quotation marks to the universal class. Let's again look in SAS. For this example, we can see all is specified for both sex and smoking status with customized labels. We can see that here as well as here. The output table displays the total counts for all observations, total counts for each gender from all smoking statuses, and total counts for each smoking status from both genders. Running the code, we can see that here. Now, comparing to the output, we can see the table displays the counts from all observations. We have the total counts for each gender from all smoking statuses, seen through here. We have the total counts from each smoking status for both genders, again seen here. And the specified labels become the row and column headings as we define the text for the variable. We can again see that here on the slide, where smoking status all equals total for smoking status is placed here, and the total for gender is placed here. Here is a list of the statistics we can get from Proc Tabulate. We can apply those keywords to obtain the statistics we are interested in. They are similar to the statistics that we would get from Proc Means, Proc Freq, and Proc Univariate. Let's look at another example. The asterisk will be used to specify keywords after the variable. As we mentioned earlier, the variable following the asterisk will be nested within the variable in front of it. You can look at the statistic keywords as nested within the variable of interest. Again, we will look at SAS. Looking at the statistics part of the code. In the first example, we would like to look at the mean age by gender along with variance and standard deviation. That will be this code right here. Comma is used to separate gender as row and age as column. We can see the commas here. 3 keywords are separated with space for age. Running the code, the procedure produces a table with 1 column for each of the statistics. We can see that here. Looking at the next set of code, we would like to look at a count and percentage of smoking by status by gender. Asterisk is used between gender and smoking status to create a nested structure. 2 keywords are specified. The procedure produces a table with 1 row and 2 columns for each combination of gender and smoking status. We can see that by running the code. Notice again we have 1 row and 2 columns for each combination of gender and smoking status. So here we have the overall female, so we have female heavy smoker, female light smoker, female moderate, female non-smoker, and looking to the right we have all the male and smoking status. We can also see that example here on the slide. this page, the example is for an analysis of variables by two class variables with the universal class variable all. All is added to both gender and blood pressure status. The output table displays count, mean, and standard deviation for each gender and blood pressure combination for each gender for each blood pressure type for all patients. Rows with light blue backgrounds are for gender and blood pressure combinations. Rows in yellow are for each blood pressure for both gender. First two rows in orange are for each gender for all blood pressure. The last row in orange is for all patients. So different from Proc means, we can actually get the statistics for all patients for all observations regardless of their group in the same table. Let's again look at this example in SAS. Here in the next section we have that code. So a couple things to notice here. We are creating titles and subtitles using the title and title 2 statements. The Proc Tabulate is actually creating the table. Here we have some different styles that are specifying those colors that you saw in the slides. Also, all is added to both gender and blood pressure status. Again, running the table. Here we see the output from the slide. If we want to display different format for the statistics, we can add format for the statistics using F equals the specified format with the asterisk operator. We change the mean age to display only 1 decimal and the standard deviation to display 3 decimals in the example. There are many other formats that you can apply to other types of values, such as time, date, and money. So the values in the tables will look much better and make more sense to your audience.